Good afternoon, everyone. I am Vishal Sakpal, faculty of Kautilya Academy. We are learning here chemistry through online classes. Okay, yesterday we have started with chapter name matter in our surrounding. Okay, so in that chapter, in introduction, we have learned related to the basic about the matter. Means what? Whenever we have classified means what? Our scientists have classified the universe on the basis. Okay, universe classified into the two parts, that is a matter and energy. Okay, so matter, what do you mean by matter? Yesterday we have discussed about it. Matter means what? That occupies space and have mass. Okay, even number of terms related to the mass as well as space we have discussed yesterday, so we will not take as much time to into this lecture. Okay, if you have doubt, then you can mention in your comment box. Through that comment box we can understand your feelings as well as your questions. Okay, so on the basis of the questions we can try to troubleshoot them. So here matter is also known as a substance. Yesterday we have discussed related to that. Okay, so mass of any matter. Okay, mass and weight, there is a difference between them, because many people get wrong conception or a wrong concept related to that. Because of mass and weight, why they are different? Because of weight can be changed according to the place to place. Okay, that can be changed according to the place to place on the basis of gravity, but there is a no change in the total content of that body. Okay, yesterday we have discussed about that. So here the next one we will look here about the classification. Yesterday we have started with the physical composition, and physical composition, that is the popularly known as a states of matter. Okay, states of matter, in that, okay, number of states are there. Okay, many people means yesterday I have asked related to that how many states are there. Okay, so you can understand there are the 6 states of the matter, okay, around us, and 6 states of matter. Among them, first state is a solid state. Okay, solid state, what do you mean by solid state? Whenever they ask you related to the solid state, you need to write this concept only. It has a fixed or definite shape and volume. Okay, means what? If you have any solid substance, then that substance has fixed or a definite shape as well as volume. Okay, it can acquire the particular area, so that's why that can be acquire the particular volume. Then it cannot be changed its shape according to the container at normal surrounding temperature. Okay, every substance has its own normal temperature, and that substance cannot change its temperature within that range. Means what? Our human body is adjusted, or means we cannot say that is adjusted, but our body temperature, normal body temperature is a 37 degrees Celsius, but whenever the temperature of the surrounding is increases, then at that instant we faces the challenges related to our body. As well as whenever in a winter we can see or we can experience, whenever the temperature reduces, that at that instant also we can faces challenges. Okay, so that is the related to the normal surrounding temperature. So here we cannot say the particular temperature is normal surrounding temperature, or that is the standard for all. Okay, so every substance has its own normal temperature, or that substance can retain its own properties as it is on particular temperature, and that is the normal temperature for that substance. So here we can say iron. Okay, iron that cannot be melted at the 37 or 30 or 50 or 100 degrees Celsius. Okay, whenever you want to melt that substance, then you need lot of temperature or a higher temperature. Okay, so at that higher temperature you can melt down. Okay, so iron is a sustainable, or it can sustain or retain its property for even longer temperature, or sorry, higher temperature. Okay, so example wood, stone, sand, etc. are the example of solid. Okay, yesterday we have discussed about the types of solid. Okay, so there are mainly two types: crystalline solid and amorphous solid. Okay, crystalline solid, on the basis of they have fixed geometrical arrangement. Okay, means what? If we have studied related to the solid crystals like as a salt crystals, sugar crystals, so they have fixed geometrical arrangement, as well as that is the definite geometrical arrangement, as well as sharp melting point. What do you mean by sharp melting point? If you have any substance and that is in pure form, then that substance has a fixed melting point. Okay, means what? If you procure the salt from the Pakistan, Nepal, India, China, US, Germany, okay, and if that is in pure form, then that salt has a fixed melting point, okay, but that should be in a pure, okay, that should be in a pure form. So sharp melting point. Then subtypes of crystalline solids, okay, yesterday we have discussed related to the crystalline and amorphous solids. Crystalline solid on the basis of their fixed geometrical shape, or sorry, fixed geometrical arrangement or internal arrangement and the sharp melting point. And another that was a amorphous solid, that is indefinite, or we can say that is a random geometrical arrangement, as well as they do not have sharp melting point, okay. And we have taken examples related to the amorphous solid, like as a plastic, rubber, glass, those are examples related to amorphous solids. So here subtypes of crystalline solids, we can learn about the subtypes. So subtypes means this crystalline solid can be classified, further classified into their subtypes, okay. Means what we can say, there are number of countries, but those countries have different states, and those states have different tehsils, those tehsils have different villages. So like that, here also this crystalline solid also classified or subclassified into the following types. So ionic solids, yesterday we have discussed related to the molecule, ion and atoms, okay. So what do you mean by ions? Ions means what? Every atom, atom is what? That is the smallest particle of the substance, okay. Smallest particle, how much smallest? Smallest means what? That particle should not be further chop down or a breakdown, okay. So that is the smallest, that kind of smallest particle is needed for this experiment or understanding, or and that particle can be considered as a atom. So here we talked about the atom. So atom has a number of subatomic particles, means that atom has number of particles which are incorporated into them, into that, okay. Number of particles are placed into that. So there are protons, neutrons, electrons, but here we are talking about the electrons. Whenever we provide the heat, or whenever we try to, means what, here atoms can lose or gain electron. Whenever they lose or gain electron, they forms ions, okay, ions. So here they can lose electron in the case of whenever we provide the heat, okay. So whenever they lose electron, they form the cations, okay, they form the cations, okay. So why they are forming the cations? Okay, because here the cations means what? That is a positively charged ions, and anions means what? That is a negatively charged ions, okay. Cations positively charged. Why cations? We can take example of the sodium here. Sodium has 11 electron, okay. If you have knowledge related to the atomic structure, then you will get this thing easily, okay. And even if you do not have as much knowledge related to the atomic structure, then don't worry, we will discuss in our 4th chapter, that is the atomic structure, okay. So don't worry about this structure, we will discuss into that chapter, but here you need to understand the basic thing related to the cations or anions, okay. So here sodium has atomic number is 11, okay, and that electronic configuration or electrons are distributed in the manner 281, means atom, okay. This is the atom nucleus, and there are number of shells around it, okay. Shells means what? Circular orbits, okay. So where electrons are distributed, so here 281, okay. So in the first orbital can occupy 2 electrons, second orbital can occupy maximum 8 electrons, and the last orbital or third orbital can occupy also 8 electrons, okay. So that's why here it has 1 electron extra, or we can say there is a requirement of 7 electrons to complete octet here, okay, because it has 1, okay, its capacity is of 8 electron, but it has only 1 electron. So there is a requirement of another 7 electrons, okay. Instead of gain 7 electrons, it can lose 1 electron easily. So that's why we can say sodium can form cation, okay. Sodium can form cation, and that form cation is a positively charged because it has one electron extra into its outer orbital. So that's why we are taking positively charged positively charged ion for cation. Okay, did you get this? This is a very simple term related to the cation and anion. Okay, so anion means what? Here we can take another example related to the chlorine. Chlorine's atomic number is a 17 and electronics configuration or electrons are distributed in a manner 287. Okay, so there are 7 electrons in its outer shell. Okay, there are 7 electrons in its outer shell. So there is a requirement of 1 electron. So we can say there is a deficiency. So that's why we can take the negatively charged for the anions. Okay, here many students get confused related to the cathode and anode also. Okay, when we are talking about the ions, okay, ions, so in that case positively charged ions are cations and negatively charged ions are anions. But whenever we are talking about the electrodes, means what? Those who have knowledge related to the electrolytic cells, and even we have learned about them into the 8, 9, 10 standard, anode and cathode. Okay, when you are talking about the anode and cathode, so in that case anode are positively charged electrodes and cathodes are negatively charged electrodes. Okay, so this is the basic concept related to the charge. Okay, so this is the very important part related to the ionic solids. So here they consist the cations and anions held together by electrostatic forces. Okay, so electrostatic forces means what? Electrostatic forces are those present between the charged particles. So here we can take example of NaCl. Okay, in our day-to-day life we are using the sodium chloride as our table salt or in our diet. Okay, as a common salt. Okay, so that salt is made up of NaCl. Okay, so sodium chloride, and Na is a positively charged because it lose one electron and that loosed electron goes to this chlorine, and whenever it acquired the negative electron, okay, means what? It has taken electron from the other atom and that is the sodium. So that's why here the chlorine is a negatively charged because it has taken loan as a loan. Whenever we are taking a loan, then we are in a negative. Okay, and if you have ample of resources, then you can donate. Okay, so here we can say sodium can donate electrons because it has a number of electrons, or there are one electron. Okay, or we can say there is only one electron in its outer shell, so that's why it can lose electron, and whenever it lose one electron, that can form the Na plus. So whenever you have a substance sodium chloride, so it look like that is a Na plus and Cl minus, and this is the ionic solid. Okay, did you get this? So we have number of examples related to that NaCl, KCl. So whenever we are talking about the KCl, so potassium carries positive charge, chlorine carries negative charge. Zinc sulfide, so zinc carries positive charge, sulfur carries negative charge. So here they are tightly held, or they held together by electrostatic force. That is, electrostatic force means what? That is present between the charged particles and different charged particles. So here we have taken the example related to the common salt, that is the NaCl, KCl, zinc sulfide, etc. Okay, the next subtype of crystalline solid is the molecular solid. Okay, molecular solid. What do you mean by molecules? Okay, means here we can take the group of atoms. Okay, when we are talking about the atoms, so in that case we need to understand that atom is what? That is a single particle and that is the smallest particle. But whenever the number of particles come together, they can form molecules. Okay, so here we have taken the examples of ice, solid carbon dioxide, dry ice, etc. Okay, solid carbon dioxide also known as a dry ice, and this could be the question for the prelim. Okay, means they will ask you related to the dry ice, solid carbon dioxide also known as, and they will provide you number of options there, or they might be asked question like that, the dry ice is also known as. Okay, so these kind of questions can be formed on the basis of this knowledge. So molecular solids means what? These are made up of neutral molecules and are held by intermolecular forces. Okay, intermolecular forces, that is the van der Waals forces, and those forces are weak in nature. Okay, those are weak in nature means what? We have ice. Whenever you provide the slight heat, means what? Whenever you if you have ice crystal, okay, or ice cube, and whenever you put that substance into the without freeze or in in your surrounding, so in that case, in our surrounding there is a presence of lot of heat. So whenever it comes into the contact of that heat, then it starts to melt down. So why? Because of there is a presence of weak forces. Okay, those forces were weak in nature, so that's why they start to melt down easily. Okay, we do not require as much heat to melt down the ice cubes. Okay, so that's why it required slight heat around us. Okay, so molecular solids are solids. These are made up of neutral molecules and are held together by intermolecular forces, and those forces also known as van der Waals forces. Okay, van der Waals means what? This is the name of scientist, okay, who had discovered about these weak forces, and the named, okay, after his discovery, that forces also known as van der Waals forces, and those forces are weak in nature. Okay, so these kind of questions can be asked in the prelim. Okay, van der Waals forces are means nature, strong, weak, or intermediate, or number of things. Okay, they will provide you. So here we need to understand van der Waals forces are weak in nature. Okay, then here we have taken the examples: ice, solid carbon dioxide. Many people would think like as a carbon dioxide is a gaseous in nature, so how it could form the solid carbon dioxide. So whenever you try to reduce its temperature, means what? That solid carbon dioxide can be formed at the minus 79 degrees Celsius. So here you can form the solid carbon dioxide, and that solid carbon dioxide also known as a dry ice. Okay, so we have two examples: ice, solid carbon dioxide, that is a dry ice, etc. Okay, did you get this second type? Okay, second subtype. Okay, earlier we have learned about the ionic solid, and then this is the molecular solid. The next one, third, is a covalent solid. Okay, covalent solid means what? It consists atoms which are held together by strong covalent bond. Okay, we will learn in detail about the bonds in the chemical bond chapter, okay, in upcoming chapters. So that's why here we are talking about the covalent bond directly. Okay, so there are number of bonds, and prominently we have idea about the three bonds, that is the ionic bond, then second one covalent bond, and third one coordinate bond. Okay, so covalent bond means what? They formed, okay, so here covalent bond, there are two types of covalent bond: polar covalent bond and non-polar covalent bond. Okay, whatever I am discussing here, that part